We talked about precipitation reactions. Let's talk about some other types of reactions now too. Oh, we also talked about acid-base reactions as well. A gas-forming reaction is an exchange reaction, double displacement, and one of the products is going to be a gas. So calcium carbonate there is reacting with hydrochloric acid to make calcium chloride and what's called carbonic acid, H2CO3. Now it doesn't look like there's any gases there, which is true, but what happens in a gas forming reaction is that one of the products is usually unstable and it further breaks down into the gas, and in this case that's carbonic acid. If you see carbonic acid, H2CO3, just realize that H2CO3 is going to break down into CO2, a gas, and water. So really this reaction should be listed as calcium carbonate plus 2 hydrochloric acids makes calcium chloride plus CO2 gas plus H2O liquid. So gas-forming reactions will form a gas, but it may not be readily available. So I would definitely know that the carbonic acid is going to break down to CO2 and water. If you see carbonic acid as a product, you know it's going to be a gas-forming reaction. Ammonium hydroxide is another common example of a gas-forming reaction. Ammonium hydroxide will also break down into a gas, ammonia, and water. So if you see ammonium hydroxide as a product, you should also know that it's going to break down into NH3 and CO2. They're both gases. They don't look like gases. They'll look like they're AQ things because they are, but they'll further break down into gas products. We'll see this in the lab. We're going to do the net ionic reactions lab.
When calcium carbonate, marble, is placed in hydrochloric acid, carbonic acid is produced, which is converted to gaseous carbon dioxide and water in a gas-forming reaction.
Here's a question you might see. It says, which equation below best represents the balanced net ionic equation for the reaction of magnesium carbonate with nitric acid? Okay, so notice it's net ionic equation. We don't want any spectators, okay? So magnesium carbonate has a carbonate, and most of the negative polyatomics, when they react with anything but group 1A and ammonium, will make insoluble compounds. So notice that MgCO3 is listed as a solid, and that's correct. Carbonates usually are insoluble unless they're with sodium, potassium, and lithium. It's going to react anyway with magnesium, thanks for playing. It's going to react with nitric acid, which is HNO3. And this is going to be a displacement reaction. So the H plus and the Mg plus are going to trade places. You're going to make magnesium nitrate on the other side. And what looks like initially H2CO3 is actually going to be CO2 gas and H2O liquid. This is a gas-forming reaction. Remember that H2CO3 will break up into H2O, which is the product there, and CO2. So it's kind of a thing you just got to pay attention to. Well, anyway, answer A is the balanced molecular reaction. It shows all the cations and the anions, but we don't want the balanced reaction. We want the net ionic reaction. So if you look at just the aqueous species, HNO3 on the left and magnesium nitrate on the right, both of those have nitrate. Nitrate is a spectator ion, and you want to pull them out. So if you pull out the NO3s, keep the gases, liquids, and solids, you can see that HNO3 goes to H+, and magnesium nitrate goes to just magnesium 2+. So answer B here is actually the net ionic reaction. It does not include nitrate because nitrate is a spectator. Good to go. A combustion reaction is another kind of reaction that's used a lot, especially in organic chemistry. And in a combustion reaction, the easiest way to think about it is you have something organic, which usually has carbon and hydrogen, sometimes oxygen, sometimes even nitrogen. And you're going to burn it in O2 because oxygen's a gas, and the products will always be water and CO2. If you happen to have nitrogen, then you'll make NO2. That's the one exception to it. So this This is actually very common, and it's used, for example, in our cars. If you have a gasoline engine in your car, then it's using gasoline, which is essentially a carbon-hydrogen compound. It reacts with the oxygen to make CO2 and water. But anyway, these are just some examples. Here's C2H4 reacting with oxygen to make waters and CO2s. The next problem down there, it's a nitrobenzene compound. You don't need to worry about that name, but it also burns an oxygen to make water, CO2, and because nitrogen is there, you're going to make some nitrogen dioxide. So combustion reactions are usually they give off a lot of energy. They're very exothermic. They're kind of fun because you get to burn things. But anyway, that's kind of the idea of what's going on.